Hey everyone, welcome to the 2.1 Intro to Matrices Notes video. In this lesson, we're going to kind of learn about what a matrix is and its dimensions, as well as how to do basic operations with them. So first thing first, let's talk about the dimensions. We talk about matrices based off of two dimensions. They're made of rows and columns. So what we're going to do is say that a matrix is, say, n by n. Okay, and what that means is that there are n rows and n columns. So when we're talking about dimensions, it always is going to go rows by columns. Now, I have a feeling that most of you already know what these are, but just to show you an example, rows go side to side like this. And what we're going to do at the edges is put a bracket that encloses the whole thing so we know where our matrix ends. Then columns go up and down. Like this. The thing is, you always count them in the opposite direction. For instance, I just drew 1, 2, 3 rows. So they kind of get counted up and down, but rows go side to side themselves. And this is 1, 2 columns that go up and down. Okay, and we can also use this to refer to entries. So for example, A2, comma 4 would be in row 2, column 4. All right, now let's talk about how to do some operations with them. So if we want to do a sum or difference, remember that sum is addition, difference is subtraction, then we would need to have two matrices that are exactly the same dimensions. Let me kind of switch up here. So if one of them has 2 rows, 4 columns, in order to be added together, you must add it to another one that has 2 rows and 4 columns. Okay? And the reason why this has to happen is, sorry about that, let me fix it. You basically add or subtract corresponding entries. Now, you might have heard the word corresponding in geometry. Basically, corresponding means in the same location. And this sounds a lot more complicated than it really is. We're going to practice it down below. So we're going to add and subtract. Then the third thing we're going to do is something called a scalar product. It's basically multiplying, but the reason why we're not calling it multiplying is because basically we're going to multiply by a number for this one. Multiplying matrices is where you take an entire matrix times another matrix. So for this one, CA would be multiplying all entries of A by C. So if C was, say, 2, you would double all of the numbers on the inside. None of the operations we are doing today are very difficult. The whole goal is just to get used to what a matrix is. All right, make sure you have all this jotted down because I'm going to scroll on down the page. Okay, so for example 1, you have over here on the left side what A and B equal. There we go. Okay, so for this first one, we are going to add A and B together. And I'm not going to show a lot of work over here. What I'm going to do is show you that I'm going to add the top left entries together. Kind of crossed it out, so let's try that again. So the 2 and the 1 are in the same spot. We're adding those together to get 3. Then the 0 and the -3 are in the same spot. So we're adding those together. 0 plus -3 is -3. And then lastly, 7 plus 2 is 9. So they have to be in the exact same spot. So first row, first column. Second row, first column. Third row, first column. Then I'm going to add together on the other side these two, because they're in the same spot. They're both the top right. -3 plus 0 is -3. 5 plus 1 is 6. And -0.5 plus 2 is 1.5. And that's it. Okay? We can also add together entries if we wanted to. So if you look down here, A3, 1 is row 3, column 1. I'm sorry, I know I wrote really terribly. So row 3, column 1 is right there. Or at least as close to right there as I can draw with my smart pens. There we go. Then, that's 7. B2, 1 is row 2, column 1, which would be right here, -3. So if I wanted to add together A3, 1 and B2, 1, I'm adding together those two numbers, which is 4. Right? This isn't what you would normally do if you were adding them together, but it can ask you in the directions to add any entries in the matrices together. Now, let's try the next one, which says A plus 3B. What that means is we're going to take A, and add it to whatever 3 times B is. And I'm going to say this out loud as I write it down, but I am multiplying everything in B by 3. So top left, 1 times 3 is 3. Top right, 0 times 3 is still 0. Middle row, -3 times 3 is -9. 1 times 3 is 3. Bottom row, they're both 2's, and 2 times 3 is 6. And then I'm just adding them together again. Now, before they were written kind of vertically, now they're written sort of just side by side. So this does change the way it looks a little bit. Instead, I'm adding together those two. Still the same idea though. 2 plus 3 is 5. -3 plus 0 is -3. 0 plus -9 is -9. 5 plus 3 is 8. 7 plus 6 is 13. And -0.5 plus 6 is 5.5. It's really not rocket science here. But it is important that we practice this because you need to get used to the format. Okay, then we're going to subtract. Guess what? The only difference is we are now subtracting instead. So A minus B. Notice how these are both 2 rows, 3 columns. These would be an example of a 2 by 3 matrix. Okay, 7 minus 6, and A0 minus 8, -3 minus 0, 1 minus 1. 0 minus -6 becomes +6. Be careful with your negatives. And 5 minus 9 is -4. That's it. One more at the end, 2a minus b. I'm going to go ahead and erase this over here. 2a, let's go ahead and jot that down really quick, is going to be on the top row, 14, -6, 0, 0, 2, 10. And then we are going to subtract b from this. Okay. 14 minus 6 is 8. -6 minus 0 is -6. 0 minus -6 is +6. 0 minus 8 is -8. 2 minus 1 is 1. And 10 minus 9 is 1. Now, I would recommend not drawing those lines every single time because it looks pretty confusing. I'm doing that for you guys so you can see my work since we are not together. All right. Go ahead and flip the page. Here we go. Find the following scalar product. That means multiply by 6, guys. So literally multiply everything in here by 6, and that's all you really have to do. Okay, 7 times 6 is 42, 5 times 6 is 30, and 1 times 6 is 6. That's my top row. Then I'm going to do my second row. 4 times 6 is 24, 9 times 6 is 54, and 5 times 6 is 30. Last row, 8 times 6 is 48, 2.2 times 6 is 13.2, and -3 times 6 is -18. That's it. That's a scalar multiplication or scalar product. You just multiply all the numbers by whatever's out front, and you're good to go. It is as easy as you think it is. Right, now let's talk about some tricky ones. It wants us to find the value of each variable. So first, I'm going to circle row 1, column 1 on every one. So 2x plus 5 has to equal 21. Then I could switch over to looking for a different one. There we go. Let's see, here's the y, so that's row 2, column 2. So 7 plus y equals 5. We just have to make sure that these are adding together correctly, pretty much, is all I'm saying. Okay? And then for the last one, z is all the way over here. It's on the equals end. And it's in row 1, column 3. So we need all the other row 1, column 3s. Meaning 4 plus 9 equals z minus 5. Now, it's not always going to be quite this difficult. Sometimes it's going to be quite easy, but I'm going to start with z since I just wrote that one up there. Actually, I'll go back to x because I have a feeling people are going to want me to do it that order. It's just an equation. Subtract the 5. 2x equals 16. So x has to be 8. It's pretty easy. Then moving on to the y. Subtract the 7. Or ask yourself, 7 plus what is 5? Well, you have to go down 2 from 7 to get to 5. So your answer is going to be -2. And then for the last one, we need to get rid of the 5 by the z. So I'm going to add 5 to the other side. And now I have 3 things I need to add together. 4 plus 9 plus 5 4 plus 9 is 13. 13 plus 5 is 18. And there you go. Hey, don't overthink these. You just have to look for each variable. And it does take a little bit of inspection first. All right, last example. Find a plus 3b. And don't freak out because there's variables that we're going to have to deal with here, okay? And this problem is looking a little funky to me, so I'm going to go ahead and do this. And I'm going to say that there's 2 rows and 3 columns in each of these. I don't know about you guys, but for some reason that just looked really funky to me. I don't feel like there's enough space in between them. So I'm going to go ahead and multiply b by 3. So now I just tripled everything. X became 3x. Negative y became negative 3y. And so on. Now I just need to add them together. So I've got 2x and 12, negative 12. So that's just simply going to be 2x minus 12. Okay? Then I need 3 plus 3x. Well, that's exactly what it sounds like. Okay? And then x plus 2 plus 6. Well, we can go ahead and add those 2 and 6 together. So that turns into x plus 8. That's my first row. Well, then I got 0 plus 3x minus 3y. Done. And then y plus negative 3 is just y minus 3. And x minus y plus 3y. Well, negative 1y plus 3y is 2y. And then you've got the x. So this one, you're really just combining like terms, and that's about it. Remember that when we talk about dimensions, it goes row by column, not column by row.